Hello everyone. So in previous few lectures, we discussed the basic signals and its Laplace transform. So now we'll quickly summarize all points and also we will discuss some new important points regarding Laplace transform. So we saw the Laplace transform of an impulse signal del of t is 1. The Laplace transform of a step signal u of t is 1 by s. The Laplace transform of the ramp signal r of t, it is also represented as tut. The Laplace transform is 1 by s square. So these are few basic signals and its Laplace transforms. Now let us find some interesting relation between these signals. First, we have relation between the impulse signal del of t and the step signal u of t. We know del of t and its Laplace transform is 1, and we have u of t, that is the step signal, and its Laplace transform is 1 by s. Now if I want to get u of t Laplace, which is nothing but 1 by s, from step signal whose Laplace is 1, I have to multiply 1 with 1 upon s. So in order to get a step signal from impulse signal, I have to multiply this 1 with 1 upon s so that I can get the step signal. So the significance of 1 upon s is nothing but the integration. Now we will discuss how the significance of 1 by s is integration in the subject signals and system. So we can say u of t, how to get u of t? U of t is nothing but integration of del of t. The detailed analysis of this part we will discuss in signals and systems. But for us, we will also require this in control system. So we are discussing here. So to get step signal, we have to integrate the impulse signal. Now similarly, if I want an impulse signal whose Laplace is 1 from a step signal whose Laplace is 1 by s, I have to multiply this 1 by s with a signal s so that these two values gets cancelled and we have only 1. 1 is the Laplace transform of del of t. So I have to multiply 1 by s by s. So the significance of s is d by dt. So impulse signal, which is del of t, is nothing but differentiation of a step signal u of t. So I hope these two relationships are very clear to you. Now let us see the relation between the ramp signal r of t and the step signal u of t. We know the step signal u of t, its Laplace is 1 by s, and the ramp signal r of t, its Laplace is 1 by s square. So if I want a ramp signal whose Laplace is 1 by s square from a step signal, I have to multiply this by 1 by s. So 1 by s into 1 by s, I will get 1 by s square, which is the Laplace of the ramp signal. So again 1 by s, its significance is integration. So in order to get a ramp signal r of t, I have to integrate the step signal u of t. And if I want to get a step signal whose Laplace is 1 by s from a ramp signal whose Laplace is 1 by s square, I have to multiply 1 by s square with s so that this s and the square gets cancelled. So I have 1 by s. 1 by s is the Laplace of u of t. So I have to multiply by s. So again s, its significance is a derivative, which is d by dt. So u of t is obtained by a differentiation of a ramp signal r of t. So these are few basic relationship between the basic signals impulse, step and a ramp signal. Now there are some exponential values. As a student of a gate, you should be aware of these values. These values you can get in your calculator, but still if you know these values, you will save a lot of time in your examination. First is the value of exponential e, it is 2.718. E raised to minus 1, its value is 0.368. Value of 1 minus e raised to minus 1 is 0.632. E raised to 0 is equals to 1. E raised to minus 0 is again 1. E raised to infinity is infinite. And e raised to minus infinite is 0. So these are some basic values you should know about the exponential signals. It will save a lot of time and we will be using these values in our subject control system in many of times. So we have discussed the basic signals and its Laplace transforms. Also we have solved some basic questions on each signal, and now we have discussed the relation between the basic signals. So this was about Laplace transforms, which we will be discussing in our subject control system. The next lecture will be the poles and zeros in the transfer function. From the next lecture, we will again resume to our subject control system.